Hello everyone, welcome to the session on digital electronics. In this session, we'll be discussing about important combinational circuit called as multiplexer. By using multiplexer, it is possible that we can construct any logic function. In this session, we will see what we mean by multiplexer and the different types of multiplexer and the design of these multiplexers. Friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Khanade, and do subscribe to the channel to see many videos on the subjects of electronics and computer science. So let us start the session with the question what we mean by multiplexer or MUX. Multiplexer, you can say, is a digital circuit. It is a combinational circuit that is used to select from the group of inputs. So whatever the input is being selected, that input is being passed to the output. So multiplexer is going to have many inputs and it will have only one output. So multiplexer is also called as many into one. Since there are many inputs, and out of these inputs we have to select one, and that input which is being selected, the data that is available on the selected input is being passed to the output, and therefore this circuit is also called as many into one. So this is a block diagram for n to 1 multiplexer where one can easily observe that there are n inputs I0, I1, I2, In minus 1. This multiplexer IC also has a strobe input or enable input G, and this is an active low input. That is, this must be equal to 0 in order to proper work of this IC. This multiplexer has some select inputs or control inputs, and if there are n number of inputs, then there can be m number of select inputs, S0, S1, S2, Sm minus 1. So these control inputs will decide which input is to be selected, and the data, whatever is available on that selected input, will be passed to the output. So you can say that the multiplexer will work just like a switch. So the inputs of the multiplexer can be I0, I1, I2, In minus 1. G is the strobe input or enable input, and this is active low input, and this must be equal to 0 in order that this multiplexer should work properly. There are select inputs S0, S1, S2, Sm minus 1, and there is a relationship between n and m such that n is equal to 2 raised to m. So if there are 4 inputs, then you require 2 control inputs or select inputs. If there are 8 number of inputs, then you will require 3 control inputs or select inputs. The multiplexer IC is very important, and it is being used where the multiple data is to be transmitted by using a single line. So there are large number of applications of multiplexer. Say for example, we can make the use of this multiplexer in communication systems or in telephonic systems. It is being used in computer memory. It is being used whenever we want to route the data. Any logic function can be generated or any combinational circuit can be constructed by using only multiplexer, and this is also used in the televisions and cable TVs. So now let us go for the first type of the multiplexer, and this is being called as a 2 to 1 multiplexer. So we will go for the design of 2 to 1 multiplexer. So as shown in this diagram, this multiplexer will have 2 inputs I0 and I1. This IC or this multiplexer will require only one select input S0, and it will have only one output Y. So 2 to 1 multiplexer will have 2 inputs I0 and I1, and it will have one output Y. This multiplexer will require one select input S0. The strobe input, which is actually not shown in this block diagram, and this is assumed to be 0 because unless and until it is equal to 0, the multiplexer will not work properly. Now we can easily construct the truth table for this multiplexer. Now we know that in order to work properly, the strobe input G must be equal to 0. When S0 is equal to 0, then you will find that the input I0 will be selected and the data which is being available on the I0 will be transferred to the output. When S0 is equal to 1, then the input I1 will be selected and the data which is being available on the input I1 will be transferred to the output Y. And when G is equal to 1, then whatever may be the S0, the output Y will be always equal to 0. Now we can write the SOP equation for the output. So we can easily write y is equal to complement of S0. The complement of S0 can be written as S0 dash into I0 plus S0 into I1. So it is possible that we can construct the circuit of the multiplexer either by using NAND gates or by using AND and OR gates. So let us construct the circuit for this 2 to 1 multiplexer by using only NAND gates. So we can draw the logic circuit for this 2 to 1 multiplexer as shown in this figure. The first NAND gate will have the input S0 dash, that is complement of S0 and I0. The second NAND gate will have the input S0 and I1. The outputs of both the NAND gates are connected to another NAND gate where the output of the third NAND gate is just nothing but the output of the multiplexer. So one can easily check that this circuit will follow the truth table of the multiplexer. IC 74157 is a popular IC, and this is a two input multiplexer IC. So this IC is being commonly available in the market, and one can easily purchase this IC. It is a low cost IC, and one can use it whenever one want to use the 2 to 1 multiplexer in any digital circuit. Now we will go for the design of 4 to 1 multiplexer. The 4 to 1 multiplexer will have the 4 inputs I0, I1, I2 and I3. There will be a strobe input or enable input, which is active low input, and therefore there is a bubble. So this bubble indicates that this is active low input. It will this multiplexer will require the 2 select input S0 and S1, and there will be 1 output. So this multiplexer, as its name indicated, is a 4 to 1 multiplexer, and therefore it will require 4 inputs I0 to I3 and 1 output Y. This multiplexer will require the 2 select inputs S0 and S1. Because when we have 2 select inputs, then by using 2 select inputs, we can have 4 possible combinations, and that is the reason there are 2 select inputs for this multiplexer. The strobe input or enable input must be equal to 0 for proper working of the multiplexer. Now we can easily prepare the truth table for this multiplexer. Now we know that for the proper working of this multiplexer, the strobe input G must be equal to 0. And there are 4 possible combinations of select inputs 0, 0, 0, 1, 1, 0 and 1, 1. When S1, S0 is equal to 0, 0, then the input I0 will be selected and the data which is available on the I0 will be connected to the output. Similarly, when the select input is 0, 1, then output Y will be equal to I1. When the select input is 1, 0, then the output Y will be equal to I2. That is, the data available on the input I2 will be made available to the output. And when the select input S1, S0 is equal to 1, 1, then the fourth input I3 is being selected and the data available on the I3 will be connected to the output. And whenever the strobe input is 1, then whatever may be the select input, the output Y will be always equal to 0. That is, this IC will be disabled. Now from this table, we can write the equation for the output. We can write Y is equal to S1 bar S0 bar into I0 plus S1 bar S0 into I1. So one can easily observe that for the first term, S1 and S0 both are 0 and therefore their complements are written. In the third term, we will write S1 into S0 bar into I2. And for the fourth term, we write plus S1 into S0 into I3. Now again, it is possible that we can construct the circuit diagram for this 4 to 1 multiplexer either by using AND and OR gates or by using NAND gates. So let us go for the circuit diagram of 4 to 1 multiplexer. So we can construct the logic circuit as shown in this figure. So this first NAND gate will have the input S1 bar, S0 bar into I0 and G bar. Many times the people do not show this strobe input in the circuit. It is assumed that it is already enabled input. The second NAND gate consists of the inputs S1 bar, S0 into I1. So according to the terms, there are inputs to the NAND gates. S1, the third NAND gate will have the input S1, S0 bar into I2. And the fourth NAND gate will have the input S1, S0 into I3. And the outputs of all the NAND gates are connected to the another NAND gate, and the output of this NAND gate is the output Y of the multiplexer. One can easily check that this circuit follows the SOP equation that we have earlier mentioned. That is, the truth table of the 4 to 1 multiplexer is exactly obeyed by this circuit. IC 74153 is a 4 to 1 multiplexer where there are two 4 to 1 multiplexers available. So this IC is a very popular IC, and whenever you want to make the use of 4 to 1 multiplexer in any digital circuit, then you can make the use of this IC. Now we will go for the design of 8 to 1 multiplexer. Now this multiplexer will have 8 inputs from I0 to I7, and this multiplexer will require the 3 select inputs or control inputs S2, S1 and S0, and there will be only one output Y. So this multiplexer will have the 8 inputs from I0 to I7, and there will be one input Y. There will be one output Y. This multiplexer will require the 3 select inputs S0, S1 and S2, because 2 raised to 3 is equal to 8, and therefore there are 3 select inputs. The strobe input or the enable input must be equal to 0 for proper working of the multiplexer. Now we can construct the truth table for this multiplexer. So there are 8 possible combinations of S2, S1 and S0. When all of them are 0, then the output will be equal to I0. When they are 0, 0, 1, then the output will be I1. When they are 0, 1, 0, then the output will be I2. When S2, S1, S0 is equal to 0, 1, 1, then the output will be I3. That is, the data which is being available on the input I3 will be coupled to the output Y. So as I said, the multiplexer is just nothing but a switch, and the control inputs or select inputs are used to select the one of the input, and the data which is being available on that input is being made available at the output. Similarly, for 100, output will be I0, I4. For 101, the output will be I5. For 110, the output will be I6. And for 111, the output Y will be equal to I7. Now we can write the SOP equation. So according to the truth table, we can write the SOP equation. Y is equal to S0 dash, S1 dash, S2 dash into I0. So dash will indicate the complement of S0, complement of S1 and complement of S2 into I0, plus S0 dash, S1 dash into S2 into I1, plus S0 dash, S1 into S2 dash into I2, plus S0 dash, S1 into S2 into I3. So in this way, according to the truth table, you will find that our final term will be S0, S1, S2 into I7. Now, as I told you that you can construct the circuit of the multiplexer either by using NAND gates, or you can construct the circuit of the multiplexer by using AND gates and OR gate. So let us go for the construction of the circuit of this multiplexer by using AND gate and OR gate. So as shown in this diagram, we will require 8 AND gates and 1 OR gate, and they are connected as shown in this figure. So the first AND gate will have the input I0, and the rest of the 3 inputs will be S1 bar, S2 bar, S1 bar and S0 bar. So here you can observe that here we have this select input S2, S1, S0, and their complements are also available. Accordingly, the input I1 is connected to the second AND gate, and the other inputs for this AND gate are S2 bar, S1 bar and S0. So in this way, you will find that according to the SOP equation, we can construct the logic circuit for the 8 to 1 multiplexer. The output of all the AND gates are connected to a OR gate so that we can get the output Y. So one can easily check that this circuit works as per the truth table of the 8 to 1 multiplexer. IC 74151 is a very popular 8 to 1 multiplexer IC, and therefore whenever you want to make the use of 8 to 1 multiplexer in your digital circuit, then you can make the use of this IC. So thank you friends for viewing the session. Hopefully you have understood what we mean by multiplexer and the different types of multiplexer and their design and how to construct the logic circuit for the different multiplexers. Thank you friends for viewing the session. Thank you all.